Great, thank you, Jamie. So to finish up, we're going to be talking about post-incident reviews, and specifically, we're going to be doing a little bit of a review on the post-incident review process that we've put in place at ANZx. ANZx is the digital transformation project behind the ANZ Plus product, and it's our attempt to rebuild the bank as a technology company. So using modern software engineering processes and practices, things like Golang and microservices and public clouds and site reliability engineering. We're going to talk a little bit about some of the different types of PIRs that you might have seen before and some of the problems that I have with some of these styles. And this is going to lead us into the process that we use, and we'll talk about some of the reasons why. We'll also talk about some of the things that are missing from our process intentionally and some of the improvements that we'd like to make. The main aim of this talk is to help you improve your own PIR process. But I also have a secondary aim, which is to introduce you to some of the safety science behind our process. And in doing so, I want to introduce you to some of the people behind this safety science, because I think there's a lot that we can learn from the people who have been studying this in other industries, like medicine and aviation and nuclear power, for much longer than SRE has been a thing. These are all people and ideas who have fundamentally changed the way that I think about the work we do. And these slides are available online, and at the end are references to where you can find out more about these people and their research. Most of what I talk about can be found in these two guides, and if you are looking to improve your own PIR process, I highly recommend checking them out. They'll take you through it step by step of what you need to do. And the first safety scientist that I want to introduce you to is actually one of our own, and that's J. Paul Reed. He started out as a release engineer and has worked at Netflix. But he's also studied a Master's of Human Factors and System Safety at Lund University in Sweden, where the topic of his thesis was post-incident reviews. Specifically, he looked at the artifacts from reviews and how they're used by different teams. And I want to start with this quote of his from his thesis. As an industry, we're not getting better at this. That is, we do not possess some inherent quality or skill that makes us automatically improve as we experience our own organizational incidents. And there's no evidence to suggest that we pay any attention to other software organizations' incidents and outages in a complete enough way so as to be of use in reducing our own organizational incidents and accidents as we observe in, say, aviation accidents. And this is why PIRs are important, because if we want to get better, if we want to learn, then we have to make an effort to do so. It doesn't just happen automatically. And a key call out here is that we're talking about organizational learning, because it's organizations who don't inherently learn from incidents. I think individuals generally do. If you break production, you're probably the least likely person to break production again. And unless we make an effort to capture and share this knowledge, it's most likely gone as soon as you walk out the door, which is why organizations firing someone for causing an incident or an outage is pretty much the worst thing they can do if they're serious about organizational learning and learning from incidents. Teams may retain some memory of these events, but they're usually as ghost stories or war stories that we use to scare people away from making changes to various systems. They rarely contain enough detail to be useful in future incidents or even just in future work. Reed talks about this in his thesis, which he summarizes in an article for ACMQ called Beyond the Fix-It Treadmill. And it's in an issue packed with other brilliant articles on the intersection of information technology and human factors. The links are at the end, and I highly recommend checking them out. But the key point here is that it's our job to make decisions. SRE work is cognitive work. Laura and Nora spoke about this earlier in the conference, and there's a whole chapter in the SRE workbook which is dedicated to discussing this. And since we're talking about post-incident reviews, we're talking about incidents and making decisions during incidents. which means making decisions under high tempo, high stress situations, almost always when we have incomplete information, and sometimes when we're barely awake. So we really need to make every effort we can to capture this knowledge and to make this process of making decisions easier. Over the years that I've been running production systems, I've seen many different styles of post-incident reviews, and we're going to talk through these and through this evolution as I've seen it, and we'll call out some of the problems with these styles that I've learned since I've started studying safety science. Please don't be offended if I criticize the method that you're currently using. This is a journey and we are all on it together, and I feel that those a few steps ahead have an obligation to help those a few steps back, because what we do as SREs matters. One of the reasons I so strongly believe in SRE is because the focus is on the customer, and I might not know it, but some of you are probably my customers, and I'm probably some of yours. So this is the first style of PIR, and that's no PIR at all. When something breaks, we might we'll fix it. We might write an email to our boss. We might log something in Jira, but there's no actual effort invested into learning from what went wrong. At least nothing beyond doing the bare minimum so that we can get back to doing it, whatever it was we were doing before the incident so rudely interrupted us. If any learning does take place, it's purely incidental. This style of PIR falls into the trap of what's known as mechanistic reasoning. It assumes that our systems are like a machine with independent, replaceable components, and that if something goes wrong, it's because one of those components failed or someone made a mistake. It takes a very static view of the world and assumes that if we can just fix all the bugs and replace all of the humans with automation, then we can get rid of incidents. We'll be fine, right? Well, not quite, because in the systems we operate, sometimes everything can go exactly as planned, exactly as they were designed and intended to do, and we can still end up in a horrible mess. The late Richard Cook wrote a short paper all about this called How Complex Systems Fail, which details the problems in this type of thinking. Specifically, he writes about how complex systems always contain flaws, and that it's the humans in these systems who act as both the the producers and the defenders of these failures. Because our systems are not safe, and they're not reliable, and they need constant attention for us to keep them running every day. And it's the humans which are the adaptable part. It's the humans or the operators who make up for the gaps in the system that were left there by the designers. And it's why, again, we need to jump at any chance we can to learn and capture this knowledge, to capture this expertise that we use to keep our systems running every day. Next up, in styles of PIRs that I've seen, is a root cause analysis. And instead of just fixing the problem and moving on, we attempt to go deeper and fix the root cause. A popular way of doing this is by asking why 5 times. This, we're told, helps us avoid those superficial fixes and instead gets us to the systemic issues. The intention here is good, but the road to hell is paved in good intentions. Firstly, asking why is problematic, because when you ask why, you often get the answer who, and this can encourage blame. If you've ever been on the receiving end of a why question, why did you do that, during a post-incident review, it feels very accusatory. You have to justify the actions you took in the event of failure. A much better question to ask is how. Another problem with the 5 whys is that it's unreliable. And I mean this in the traditional sense of reliability, that you can repeat a process over and over and get the same result. But with the 5 whys, every time we do it, or if we do it with 2 different teams, or even with the same team on 2 different days, you might end up with a different result. At each why, we need to make a decision as to which path we take. And each time we make a decision, we dismiss a whole other branch of potential causes or contributing factors. If we find a different root cause, it means we're going to fix a different thing. And if our goal is to find things to fix, this is great, but we hardly need to spend an hour asking why 5 times to find more things to add to our backlogs. And if our goal is learning, if it's truly understanding how our systems operate, then failing to explore each branch of these whys is neglectful at best and negligent at worst. I have the same problem with the term root cause because, again, I think it's dismissive. When we say the root cause of the incident was X, we neglect all of the other contributing factors, the things that had to be present in order for the incident to occur. Each necessary, but only jointly sufficient, as Dr. Cook so succinctly put it. I used to get a little bit triggered when I heard people talking about root cause. I'd throw my arms up and go, there is no root cause. But now I get genuinely curious. I want to know, what do people mean when they say root cause? And how did they decide that this was the root cause? Most of the time, what people mean is what they intend to fix. And this depends on their role and their experience and who they're allowed to criticize. Are they a developer or a DBA or maybe a manager? If you ask each of these people what the root cause was, you will probably get a different answer. I was in a PIR a few years ago where 2 teams spent almost the entire hour debating on what was the true root cause of an incident. Was it the fact that an API had changed? Or was it the fact that a team was relying on an unversioned API? The answer to the second question, how did they decide that this is the root cause of the incident, is usually the thing they intend to fix. It's the triggering event or the latent bug which was so obviously going to cause an incident if it wasn't fixed. But it's only obvious now because of hindsight. If it had been so obvious before, well, why didn't we fix it then? And I think the answer to this is because either we didn't know about it, or if we knew about it, we were busy fixing other things and this was just one of the many issues in our backlogs. Or potentially, we weren't fixing this bug because we were working on features. And this isn't a criticism. Our systems exist because they do useful things, because they have features. And we have to find the balance between working on features and working on reliability. And this balance isn't always easy to get right because we can't see where that tipping point is. We can't see where the boundary between acceptable and unacceptable performance lies. Not at least until we've crossed it. Rasmussen illustrated this with a diagram, and in the middle we have work, and it's surrounded by boundaries on 3 sides. On one side is the economic boundary, and if we cross this, we go broke. Our finance departments make very sure we stay well away from this one. That's their job. On the other side, we have a workload boundary, and we're pretty good at defending this one ourselves. There's only so much work that we can get done in a day, and if this boundary pushes us for too long and we push back for too long, that's where burnout lives. Courtney spoke about this earlier, and if you missed her presentation, I highly recommend going back and watching it because it's an excellent talk all about this boundary. But the third boundary is failure. It's the difference between acceptable and unacceptable performance. If we had infinite money and infinite time, we could stay well away from this failure, but we don't. And the drive towards efficiency is constantly pushing us towards this boundary. And as I said, we can't see it until we cross it, and then something's gone wrong and it's too late. Moving on to the third style of PIR, and this one's more of a flavor because you can kind of apply it to any of the others and the results are still the same. But the idea is that someone has heard that PIRs are meant to be blameless, and so they make sure that we can't blame anyone because when they write up the PIR, they redact all the names. But being anonymous isn't the same as being blameless. Again, the intentions here are good, but we've lost the meaning of the message. This concept of blameless was first popularized in technology by John Allspore when he wrote a blog post for Etsy entitled Blameless Postmortems. In fact, most of what I'm talking about today can be found in blog posts that John wrote over 10 years ago. As far as I know, John was the first from technology, from large distributed internet-based services, to start taking system safety seriously. He was the first to study Masters of Human Factors and System Safety at Lund, and he wrote his thesis on how operations teams make trade-offs during pressure during internet service outages. At Lund, one of John's professors was Dr. Sidney Dekker, who writes about blameless in many of his books, and he has a lot. One of them is The Field Guide to Understanding Human Error, and it's widely considered the introductory text to the field of safety science. In the book, Dekker talks about how to understand an accident or an incident. We need to put ourselves into the shoes of those involved to try and avoid hindsight bias, which makes the outcome that we know happened now seem like the only possible outcome. He likens this to being in a tunnel which twists and turns, and from the inside we can't see where each twist and turn is going to take us, but from the outside it seems obvious. But I think there's a better way to understand what it truly means to be blameless. And that's from another of his books, another of his concepts known as second victim. In an accident, those directly hurt are the first victim, but those who weren't hurt themselves but contributed to the accident happening, they're the second victim. A train driver who was involved in a derailment, or a surgeon who was involved in a complication. Most of the resources post-incident are directed towards the first victim, but those that were involved can also suffer from trauma and a personal sense of guilt for what's happened as well. And this is no different in technology. Having been personally responsible for my fair share of incidents, I can say that this sense of guilt can be enormous. When we're truly being blameless, we understand that it's not our fault. Pointing the finger at the human is easy, but we need to look at the system as a whole to understand how was it possible for the human to act in such a way that resulted in harm. In recent years, the concept of blame-aware has started to replace the term blameless. And this is an acknowledgement that humans are somewhat hardwired for blame. We can't be blameless no matter how hard we try, especially towards ourselves. The fourth type of PIR is similar to the 5 whys, but instead of dismissing each branch, we explore it. We go back as far as reasonably possible and explore each contributing factor. And we do this, and when we do this, we draw a causal map. This can be very useful for showing how there were many latent conditions and advert failures that needed to happen for the incident to occur. It's also useful for showing that there were actions and things that occurred at the sharp end close to the incident by the operators, and as we move back from those, we get to decisions and things that happened at the blunt end, things that managers sort of decided would be the way work was done. This concept of sharp end and blunt end was first introduced by James Reason to differentiate between where the work is done and where those decisions are made. The important thing here is that the decisions at the blunt end in those meeting rooms and those managers' offices can have a huge decision or a huge influence on how the work at the sharp end actually gets done. But in the wake of an incident or an accident, the sharp end, or the blunt end, is usually far enough removed to avoid the same level of scrutiny that's placed onto the sharp end. Those sitting in offices making decisions and writing policy don't have that same level of scrutiny as those with their hands on the tools or hands on the keyboard. Reason captured this concept in what's probably the most famous model from safety science, or at least it's the tastiest, and that's Swiss cheese. Reason uses this model to show that between any hazard and accident, there is a layer of defenses, and there needs to be holes in each of these layers for the accident or incident to occur. This model is often criticized for being too simplistic, and Reason was one of the biggest critics of it himself, but its simplicity can help explain its pervasiveness. But causal maps and Swiss cheese, they're still based on the concept of linear causality, which is problematic in complex adaptive socio-technical systems. The defining characteristic of a complex system is that it has emergent properties. Novel and unexpected things happen only when all of the parts are operating together, when they interact. You can't break a complex system down into its smaller pieces, study them individually, and make predictions about how the system as a whole is going to work. Decomposition doesn't work. This can be challenging for us as engineers because decomposition is exactly how we've been taught to work on large problems. So naturally, we want to use it to understand the systems that we operate. To make things harder, complex systems are also adaptive. The outputs feed back into the inputs. There are loops. This means that small changes in one place can have a large effect elsewhere in the system, often far removed in time and space from where the initial change occurred. And this is why linear causality can't be used to explain them, because you can no longer draw a straight line between cause and effect. And even if you could, the systems are constantly changing. They're not static, they're dynamic. So that line that you've drawn isn't going to be in the same place or in the right place for very long. We often think of the systems we operate as purely technical, made up of machines and code, and as engineers, this is what we're comfortable with. But a large part of our systems are social. They're made up of people. They're socio-technical systems. The purpose of a system is to solve some problem for people and to do some work. And we as engineers and designers and operators, we're also part of the system. If you take us away, the system stops working, it stops doing work, and it stops being a system. This idea is explored in depth in the Stellar Report, which is a paper that all about IT or complex systems and IT failures, written by Dr. David Woods, who's made a career of studying complexity, starting with the 3 Mile Island nuclear power plant disaster in 1979. And just as the 3 Mile Island disaster was first attributed to human error, we often also reach for human error as the cause of many of our incidents. But this is mostly because humans are proximal to our incidents. They just happen to be close by when things go wrong. This is a byproduct of the way we typically investigate incidents. When we start at a bad event and work backwards, you inevitably find humans, and you can inevitably find humans making decisions and taking actions, and inevitably some of those can be classed as bad. Not because the humans are bad or they're doing the wrong thing, but because this is how normal work gets done. If we trace back from a good event, you're also going to find people, and you're going to find where people aren't following the procedure, where they're taking shortcuts, because this is necessary in order to actually do things. In fact, if you follow all of the rules to the letter, it's a form of industrial action known as working to rule, or my favorite, malicious compliance. And doing so will grind a system to a halt. It's also not as straightforward as simply choosing which rules to ignore or which shortcuts to take. Often, procedures and processes are ambiguous, and what seems straightforward on paper doesn't map to the real world. Another of the problems with this is that the processes and procedures we put in place can be in conflict. And this is almost inevitable when our response to most incidents and outages is to add another rule to update the procedure. Okay, so we've now talked about 3 different styles of PIR and 1 flavor. We've had no PIR at all. We've had root cause analysis, or the 5 whys. We've had anonymous instead of blameless, and we've had causal maps. And we've talked about some of the problems with these. So knowing this, what do? We run what can best be described as a blame-aware after-action review. The focus is on understanding what happened, on learning, and there are 2 parts to this. There's the post-incident report, or the write-up, and the debrief, or the post-incident review meeting. And I'm going to talk through the process in the same order that we approach it. So let's assume that we've just had a big incident, and maybe it was a big one or maybe not, but what's important to recognize is that the size or severity of an incident doesn't have any impact on how much we can potentially learn from it. A bigger incident does not necessarily mean more learning. In fact, bigger incidents generally have more eyes on them. They're more political, and it can be harder to get things, to get real learning out of it because there's more pressure to get things wrapped up quickly. Executives and maybe even shareholders need to know that something is happening, something is being done. But it's important not to rush the learning process because it does take time. A lot of places have a policy which says you have to have a post-incident report published within X days of an incident, and I think this is a mistake. By all means, acknowledge the incident, especially publicly if you're able to. But internally, you might want to hold a what we know about X incident meeting. This should also be blame aware, and you should avoid hindsight bias where you can and avoid counterfactuals. Don't jump into creating action items, but instead discuss what you do actually know about the incident. Importantly, take notes. Next, in our process, we need to decide if we're running a post-incident report or making a post-incident record. A record is a lightweight write-up that captures just the high-level details of the incident, but importantly, it points to all of the places that we can go to capture more information or to find the further information. The details which quickly get lost after an incident, the Slack posts, the incident numbers, the emails, the JIRA tickets, the things that are really hard to search for unless you know exactly what you're searching for. We also capture the impact of the incident both for ourselves and for our customers, and we include any triggering events. Was there a change, for example, as well as any contributing factors that we're aware of. Ideally, we would be able to do a full incident report and a full analysis for every incident that we have, but realistically, this isn't going to happen. If we enforce this policy, it would only reduce the quality of those incident reports that we do get, and we would prefer a few well-written reports that we can really learn from than a lot of half-finished or rushed ones with no actual detail in them. The process to capture the information to put into a record generally takes about an hour, and most of it can actually be done during the incident itself. Theoretically, with the information we've captured in there, we would be able to go back and write a full incident report based on this, but we've never tested this. For an incident record, this is where we stop. But if we're writing a report, we use all of those other data points to start detailing a timeline. We step through each system and capture the chat logs and the pipelines and the tickets and place them into our document in chronological order. This can take some time, often a day or more, as we step through each system and try to figure out what's related and what's important and how best to capture it. As we do this, we try to capture as many screenshots and system diagrams as we can, because walls of text are really hard to read, and that's the ultimate goal of our post-incident report, is to be read. And this goes for assumed knowledge as well. Acronyms and jargon always need to be explained in our reports. And even the purpose of the system should be explained, because not everybody reading the report is going to know intimately what this system does. Optimizing this document for reading means that when we're writing it, we jump around a bit. We actually start at the bottom and work back up, which makes it a little bit confusing as we're writing it. But we're only writing it once, and we hope that it's going to be read many, many times, so this is an acceptable trade-off. Sometimes we might hit a dead end in this process, which is a sign that we need to reach out to people to find more information. And this is something that we actually should just be doing more often, because often this can be really helpful for us to uncover paths that we didn't even know existed, to explore whole chains of causal factors that we didn't know about. And if we had waited until the debrief to ask these questions, we wouldn't have an opportunity to uncover them. Finally, when we write up the report, we write a narrative, and it's just that. It's the story of what happened. It's what you tell your colleague about the incident over coffee or at the pub. And this is our opportunity to add some color to the report. It's where we can capture feelings and beliefs about what were happening, things that are hard to capture in that very factual timeline. We encourage the narrative to be written in the present tense so that when you're reading it, you're brought along for the journey. The reader's brought along for the journey, even though they know how the story ends. And now, having captured the incident impact, the narrative, and the timeline, we're ready for the debrief. First up, we set the ground rules. And this is where we remind people that we are trying to be blame aware, and we want to avoid hindsight bias and talking about counterfactuals. And we're going to assume local rationality, which is that everybody made the best decision they could with the information that they had. It can be really tempting to skip this process, especially when you've run a few, and especially when you're in a room full of familiar faces. But it's important to run through it every time because it does remind people of the intent of the session. It also reminds people that it is a facilitated and semi-structured session, which can be really useful, especially if things get heated during the debrief, which sometimes happens in incidents. I've included our ground rules in this slide pack at the end. They're available for you to take inspiration from or literally just take if you want them. Next up, we will typically spend about half of the debrief session walking through the timeline. And we do this to recreate the incident as it happened from the perspective of those involved. And while this doesn't eliminate hindsight bias, it does help reduce it. When you look at the signals and the screens that were present, when you put yourself back into that tunnel, you stop asking, how could they be so stupid? And you start thinking, oh shit, I would have done exactly the same thing. As we do this, we ask questions. We get people to explain stuff that doesn't make sense, and we get them to explain stuff that does make sense, and we get them to describe what normal looks like. The key here is that we're spending our time focusing on what actually happened, not talking about counterfactuals, things that didn't happen. Instead of saying, why didn't they just zig, or saying they should have just zagged, we're looking at the signals and the screenshots of our monitoring tools and the logs from the incident and imagining what would I do next. This lets people who weren't present think through the situation about what they would have done. It's similar to a technique known as shadowboxing, which is used to build expertise without getting direct experience. And it's used heavily in industries where getting direct experience can be really challenging. Things like firefighting or in the military. The next part of our debrief is an open discussion about the incident, and we have some prompts to drive this conversation, and we use these prompts to categorize sort of the results of those conversations. But these are just prompts. We don't accept the first answer as the end, but use it to go deeper. We got lucky because Brendan was on call, and Brendan knows how the system works inside out. Well, how does Brendan know this? And do other team members know this? And how can we share this expertise? These categories also drive the incident analysis process and identify common themes across multiple incidents. We make a point to capture what went well, because if we don't, we might make changes which undo these things. It's also a good chance for people to call out when team members were particularly helpful. And it's good to recognize that some things did go well during the incident process, because every incident can be worse, and a PIR shouldn't be all doom and gloom. Finally, we spend some time brainstorming some ideas for what we would do if this incident was to repeat. But we make zero commitment to doing any of these, so people are free to suggest whatever they want. And this sometimes results in people suggesting things which seem wild and unrealistic. But a funny thing happens when enough people start to suggest the same wild and unrealistic thing in enough post-incident reviews, they start to seem a little bit more realistic every time. For most people, the end of the brainstorming is the end of the post-incident review process. We thank them for their time and tell them that we might be in touch. But our process doesn't end there. We then review the PIR as an SRE practice, which means that all SREs from all of our squads are invited, and we'll read through the narrative, we'll read through the impacts, we'll read through the lessons and the possible remediation ideas, and we'll use these to generate a set of recommendations. These recommendations aren't action items. They're much more generic. We don't say upgrade package X to version Y. We recommend that packages be kept up to date. The idea here is that we can use the recommendations from any PIR and apply them to almost any team and any service. These recommendations should, and they do, feed back into our production readiness review process as well. And not every PIR ends up having recommendations. Sometimes shit does just happen. We did everything right and we just got unlucky. So if we don't feel that the recommendations are coming naturally, we don't force them for the sake of it. The recommendations then get written back up into the report, and the report will be published, and we'll share it back into the incident triage channels that happened, as well as a dedicated channel we have for discussing post-incident reviews. The SRE team for the service is then responsible for discussing the recommendations with the teams involved. Most of the teams have a weekly catch-up with SRE where they'll discuss their SLO performance and other reliability concerns, and this is where that happens. And we usually leave it there. We trust that teams and product owners to prioritize their own work, and we're not going to force action items into backlogs just for the sake of it. We saw yesterday in Piers and Catherine's talk what happens when you do force things into action items. You get very pretty graphs of like the action items going up and never actually being resolved. But sometimes we might force action items on teams for repeated incidents or repeated fast burn alerts which are waking us up, or if a team has a fully depleted error budget, then we will take more concrete steps to make sure they're taking steps to actually fix the reliability of their service. So I want to finish up, and we are getting to the end, by calling out a few things that are missing from our PIR process. And the first is action items. J. Paul Reed's study of post-incident artifacts found that remediation items or action items are actually the most common thing in post-incident reports. In fact, over 90% of report styles have them, but we've explicitly chosen to leave them out. Why? And it comes down to intent. If your intent is to keep busy by fixing things, then action items are great. If your goal of running a PIR is a warm and fuzzy feeling that you've taken care of the root cause and this incident can never happen again, then a long list of action items is really great. Action items help people feel better about an incident. It gives them some closure, because let's face it, incidents can be unsettling, and one of the purposes of incident investigation is to assign some moral responsibility for the harm that was caused. But this isn't why we run PIRs, and we use them to learn how our system works, and we use them to uncover the expertise that we use to keep them running every day. Our intent is organizational learning, and action items during the PIR process are a distraction from this goal. We still fix things, but we don't focus on the fixing. We still have action items. The teams will generate these based on the recommendations that we make and based on their own learnings from the incident. But we explicitly avoid the focus of our PIR process being on generating action items. It's a catch-22. The best way to avoid future incidents is by not trying to avoid future incidents. Because if we focus on learning, then fixing will naturally follow, and good fixing. But if we focus on generating a list of action items, then there's no guarantee we're going to learn anything at all. The next thing that's missing from our reports is incident metrics. Mean time to detect, mean time to recover. And I get that we want to improve these things. And I get that high-performing teams have lower metrics or lower numbers for these, but they're lagging indicators. Measuring them doesn't actually help us improve them. Again, it's a distraction from our goal of organizational learning. And they're far more malleable than most people are comfortable to admit. Comparisons are really only fair when you're comparing similar things, apples to apples, and incidents are rarely similar enough that you can actually make a fair comparison. If you are having enough incidents that you can make fair comparisons between them, then maybe you shouldn't be focusing on measuring things, and maybe you should spend your time learning so you're actually getting better. Okay, but if we're not measuring things to seeing if we're getting better, how do we know if we're getting better, and what do we report up? And the answer to this one is easy, because we already have a much better tool to show the impact our incidents are having and if we are getting better, and that's service level objectives. They're way more useful for quantifying the impact to our customers than counts of arbitrary categories. 1 P1 and 5 P3s, great, that doesn't actually tell me anything about what our customers went through. And who decides what's a P1 and a P3 anyway? But if I say we missed our availability SLO by X amount this month because of these incidents, then I can start to get a real feel for what our customers actually experienced. Okay, so wrapping up now, and our process isn't perfect, and we're always trying new things and seeing how they work and experimenting, but there are a few things that we know we need to get better at. And the first of these is using neutral facilitators. We tend to default to having the SRE, who was IC for the incident, own the report and facilitate the debrief. But this means they can't contribute in the same meaningful way as everyone else present during the debrief. We do this for major incidents, but we don't do it often enough. It should be the default to have a neutral facilitator. Then we have our tooling. We use a wiki for our incident library, and it works. We have a template with hints on how to fill it out, which kind of works. But we'd like better analytics, and we'd like better categorization so that we can detect trends and themes across incidents. Being able to pull in a whole Slack channel or a Teams transcript or the history of a ServiceNow ticket would save us countless hours. But I do want to call out that this is a good reminder that you don't need anything fancy to do this. Start where you are and use what you have, and if all you have is a wiki, then that's fine. Finally, we don't do any near-miss analysis or spend any time looking at when things actually go right. But I imagine that as we get better, we might need to do more of this because of what's known as the safety paradox, which is where when you learn from incidents, you get better and you stop having as many incidents, so you stop having as many opportunities to learn. So then you need to start looking at the things that were near misses when things nearly went wrong. And then you need to start looking at just normal work. And the great thing about this is there's far more normal work than incidents. Most of the time, things usually go right, and you can learn a lot from this rather than studying the few times that things occasionally go wrong. So that's our PIR process, and in summary, we've made a really subtle shift from the goal of our PIRs being on fixing to being on learning. And by doing so, we've learned a lot. Thank you.